Hello everyone. This is Zerodha's website. It is used to trade stocks by mutual funds, etc. etc. A lot of money goes in here, comes out of here. So one could say that it's a pretty important website, especially in India. Then there is ChatGPT, another important website because a lot of you are not able to sleep peacefully at night without talking to this chatbot. I'm not making fun of you. I'm just saying that yes, I understand your needs. It's an important website to you. There are other such important websites like Gmail, like your bank's website, which you use to make important transactions, send a lot of money, hopefully receive a lot of money as well. So the point that I'm trying to make here is that if any of these websites were to go down, it would cause a lot of problems for you, wouldn't it? So the engineers at the organizations try to plan the system in such a way that it is fault tolerant. So that is the title of this video. That is why we are here. So let's talk about it. So fault tolerance, it basically means that a system should stay up even if one or more of its components end up failing. So the server goes down or some issue happens at the data center where it's getting its data from. If any of these things happen, the system should continue to serve traffic to users. That is what you have to keep in mind if you're building a system that is scalable, that is big, that serves a lot of traffic, involves a lot of money. So that's what fault tolerance means. Question is, why do we need it? Well, the answer is pretty obvious, isn't it? We need it because we want to minimize our downtime. So it sounds pretty simple. We want to minimize our downtime. But what does that mean in other words? In other words, it means that we want to restore our website if it goes down as fast as possible. Why is that important? It's simple. If a website or an app like Amazon goes down maybe for a minute, they may face not too much backlash. Some orders may get misplaced, some data may get slightly corrupted, but not too big of a loss. But if it goes down for, let's say, 3 hours, 4 hours, it's a huge problem, right? It's a lot of revenue lost for the company. So they have to design it in a way that it does not go down basically forever. That is why we need fault tolerance. But that's quite obvious. What's not obvious is the type of issues that you may face for which you need to plan for. So the types of issues could be many, but the three main issues that you face are related to your hardware. What kind of issues could you possibly be dealing with here? Maybe your server goes down. That's what we hear so frequently, right? That Instagram server is down, YouTube server is down, something is down, something else is down. So that's what we hear about frequently because it is an issue that tends to happen in a system. Why? Because maybe CPU overusage, memory was full, or there was a power failure. That sort of thing can happen, so you have to be prepared for it. And we'll get into the solutions in a bit, don't worry. I'm just trying to list out some of the issues you may face and need to plan for. Second could be your software issue. What kind of issue could this be? Well, let's say a developer makes a mistake. So let's say they did not handle a certain query well. Maybe the query was supposed to return data, but there was no data in the database for any particular reason. That should have been handled by the developer, but it wasn't. Or maybe you were trying to connect to a certain resource, and that resource somehow does not exist anymore. Maybe a website that was old, or a library that is not maintained anymore. So that is also a possible case where a software issue might be in place. Or you could be facing a network failure. Maybe the network wasn't configured correctly by your DevOps team, or it could possibly be an issue related to the environment. Maybe it rained a lot, or maybe some due to some event, jammers were placed in the area because of which some network connectivity was affected. So all these issues have to be taken care of, right? Because a good example is not just that of a data center. Maybe a network failure could happen at the data center, but it could also happen at your end. Maybe your Wi-Fi went out. or you are, like I said, in an area with some jammers in place, like a military area. So your application needs to kind of be prepared for that situation, like WhatsApp, for example. So you've noticed in WhatsApp that whenever you don't have internet, you keep on sending messages, and once you have internet, it then sends these messages to the users, right? So that basically constitutes in your network failure. They are prepared for it. So that is what are the kinds of issues that you may face in, for the most part. So question is, how do you deal with such issues? So a lot of it has to be around copying. What do I mean by copying? A more formal, refined term for it is introducing redundancy into the system. This is step one. We are going to discuss two more, so stay tuned. We introduce some redundancy in the system. That basically means we add more servers into the system than are maybe needed. For example, if your website can work on 3 servers and balance the load between them, that's good, but it is best to keep 4 or 5 servers in place in case of a spike in traffic or in case one of them goes down. So one thing that you can do is add duplicate servers. That's basically what you would call horizontal scaling. And I've discussed horizontal scaling in another video in this very series. So I would suggest that you go watch that if you're interested. You would learn a lot. So coming back to this one, you can add duplicate servers to deal with that problem. Because if you have, let's say, just one server, and if it goes down, the website will just stop working, right? So your app should have the option of interacting with multiple servers. Maybe you can rotate between them, give one call to this one to this, one to this, and if one of them goes down, you can just talk to these two while this one is restored. So that's what you can do for servers. Similarly, for databases, you can have what they call replicas. Right? There's something called read replicas and something called write replicas. So read replicas are just copies of the database, which could be demonstrated like something like this maybe. You have a database over here, your main database, right? This is what you are talking to and putting some data into. This database constantly keeps copying data to some backup DBs, very badly drawn backup DBs. And so what ends up happening is that you can not only read data from this one, you can also read data from this and this one. So how does this help us? This helps us in the case where, let's say, this database goes down, you can still continue reading from these two databases. The system still stays up, even if the write operations are affected for a while. Write replicas are just similar to that you have more databases where you can write and maybe less databases from which you can read. So just the invert of that. But the main point here is that you get multiple copies of the same thing so that in case one goes down, you get more options to continue reading from. All right. So that is what replicas means. So again, servers, you can copy them, databases, you can copy them. And it ends up serving two purposes. First is not only to act as a backup in case one of them goes down. Second is to just distribute the load when all systems are healthy in the first place. So if all systems are healthy in the first place, but we are using every part of our hardware, that is what's called an active system. So all components are being used actively by the users. Well, so you would ask, okay, yeah, that makes complete sense. So if you have all this hardware at your disposal, you would use them, right? Not always. There's something called an active passive system. That means that a user will continue talking to only one part of the system. Let's say this is you. You are talking to your load balancer. And I've talked about load balancers for a brief in the same video on scalability. So you can visit my channel for that. So you have your load balancer, and your load balancer, what it does is that it talks to one part of your system, which could have multiple servers. And let's say these servers are deployed in Mumbai. Their location does matter. There's a reason why I'm mentioning this. So this is your active system, that your load balancer is constantly talking to your servers, getting responses from them. But we also have this passive connection made to maybe some servers in Hyderabad, which are maybe not as many in number, maybe just two for every three servers in Mumbai, maybe less. So why do we need this? We need this because if the active servers end up going down for any reason, maybe there was an attack, maybe there was a power failure, maybe it was something else, we can automatically switch over to this particular path and serve traffic from Hyderabad. So that is what is an active passive system. This happens when a failover happens over here. So you move to your backup, right? Backup is the easiest way you can understand this. So a good active passive system, it needs two things roughly. First is some data with respect to the failure that actually happened, so that we know what actually went wrong and we can work on restoring that as soon as possible. Second is to keep systems decoupled or isolated. That is why I mentioned the locations, that you can have one part of the system in Mumbai, another part in Hyderabad, so that if Mumbai gets affected by floods or anything else, God forbid that shouldn't happen, but if it does, we still have Hyderabad. And Hyderabad is not affected because Mumbai was affected. So, two isolated systems. So, that is what you need in an active passive system. So that's as far as redundancy goes. Second thing that you need to do to plan for an effective fault tolerant system is monitoring. You should integrate your services with maybe some third party apps, or maybe you could make your own app, which would be a little difficult at first, but it is not impossible. You can integrate that system with your application. So if you have your servers anywhere in Mumbai, Hyderabad, wherever they are, a system should constantly keep track of the traffic that is being served by your servers over here. And this server basically should keep sending some traffic metrics, so that you know what kind of speed is your server responding at, if it is even active or not. So if it goes down, if all of them go down or one of them goes down, this system would know. What will the system do with this information? It can, first of all, document it for future purposes. It can also notify users, the developers who are working on the system, preferably. You can notify these users so that they can get on the job and fix this problem as soon as possible. So you could use a tool, let's say like Prometheus, for monitoring, and a tool like Grafana, which could help in observability or show some fancy graphs related to your service and how well it is performing, how fast it is responding, etc. So they are just two tools. There are many available in the market. I'm just naming two off the top of my head here. So you can explore these for monitoring. The third part is graceful degradation. It sounds very fancy, but what does it mean? It means that in case of a failure, which is maybe not very much in our control and may take a lot of time to fix, what you can do is degrade your system in a manner that doesn't bring the whole system to a halt. It is still graceful enough. Your users are still able to use some parts of it. So what you do in this particular step is you prioritize your critical services or critical features. For example, if you are on YouTube and some crash happens over there, some major failure, they would ideally have a system in place so that only some parts of their system remains up while the other can remain down for a while, it does not impact business too much. For example, they would have their video player working in this emergency system. Their authentication system has to work so that a user can log in. The user is not locked out of the system in any way, right? Or they could have, let's say, their search feature working in such a case, even if it may not seem so important in hindsight, but let's assume that it is important enough for them. And ads, that is how they earn their revenue, right? So ads has to stay up. And what they could deprioritize maybe is they could deprioritize maybe the comment section. It may not be as important to be had up for this particular duration, or your likes, like, or your subscribe functionality, or the YouTube analytics section for the YouTubers. So these systems can maybe kept down while we are trying to figure out what is wrong over here. And this could especially come in handy in case your system is attacked by hackers. So when hackers attack the system, what usually ends up happening is that they overload the services and you end up paying a lot of cost for keeping these services up. So it's a good idea to just cut them off for a bit and not let them affect other services that we need to be up. That's what graceful degradation means. So you can have that. Now, the next part that I want to talk about is how can we measure something like fault tolerance? Well, a good way or a common way that companies use is the concept of nines, like the number 9, right? So let me just write some of this down. So the concept of nines basically says that the more nines your system satisfies, the better it is. For example, if your system is two nines compliant, that basically means that your system is up for 99% of the time. So this time frame is usually measured for 1 year. So 99% of that of uptime would mean that your system was up for the entire year except 3.7 days. So it was down for 3.7 days in a year. So if your system satisfies three nines, similarly, it's up for 99.9% of the time. It was down for 8.8 hours. Similarly, 4 nines, 5 nines, and so on and so forth. Question is, why do we need this? Well, there are two main reasons. First is quality control and criticality. So you want the best system possible, right? So the more critical your system is, the more it should stay up, like a bank website, right? It should stay up for as long as it possibly can. Possibly it should not come down at all unless it's a scheduled maintenance activity. So that is what we need it for. That's part one. And that is what we also classify as SLO, service level objective, that you want your system to be up for this point of time, or your APIs should deliver results in, let's say, less than 100 milliseconds. That's your service level objective for each application that your company has. There is an objective, there is a metric, there is a benchmark that it has to follow. Then the second reason is, well, this could be a contractual problem. For example, AWS, I don't know the exact number, but it guarantees a certain number of nines for its services. So that's what's called a service level agreement. So by contract, they have to ensure that their service is up 99.9% of the time in a year. It cannot be down for more than that, or they may have to pay some penalties to their clients. So that's just an example, and numbers may vary, so you can verify that on their website, and I'm sure it's publicly available somewhere. So that is how you measure this. So this is a good way to keep the quality of your website in mind whenever you're building something. And that's all I wanted to talk about this video. In the next video, we'll talk about another cool concept related to system design. So stay tuned and follow for more.